All right, good morning. Welcome to our webinar about the wholesale energy transmission value tool, um, and also about some interesting trends in transmission value from 2025. So this is about our tool. It's called the Energy Market Value Tool Stage 1. And as indicated by the Stage 1, this is planned to be part of a larger project with later stages developing the capabilities beyond what we're going to show here. Uh, Later stages might look at not just transmission value, but values and prices throughout the wholesale energy markets, including looking at the potential value of new generators or the potential price impacts of new loads. But today we're going to be focused on transmission value, our stage 1 results. But if the other topics are interesting or intriguing, stay tuned and we'll have some updates in the next months and year. Okay, a couple of housekeeping points. Please use the question and answer function to talk to us. So questions, we will address some questions during the presentation and probably save most of them for the end. But we'll be monitoring the Q&A. The chat function is not, we're not going to use the chat function much in this webinar. And after this introduction that I give, Julie Mulvani Kemp, who's my colleague on this work, will lead you through most of the content, and then I will be back at the end to do a live demo of the tool. Okay, we can go to the next slide. We want to acknowledge our support for this project, which is from the Office of Electricity in the U.S. Department of Energy, and specifically, we'd like to thank Nikki Rogani for supporting this project. Okay, we have a couple objectives in this webinar, and one is just to present and inform you about some interesting recent trends and patterns in transmission market value, and that is sort of the hook for demonstrating the capabilities of the visualization tool. So don't think of this, or please don't think of this webinar as like a full comprehensive report on transmission value in 2025. The main goal is to demonstrate the visualization tool so that you can explore those trends more on your own. At the bottom here, we've linked to 2 publications on this tool, and those publications, especially the article that's in the peer-reviewed journal Nature Communications, have lots of details on methods and caveats about the values we present. So if you're really going in depth on the data within the tool or the tool itself, I really recommend looking at those 2 publications. The second one is a report that we made to support the National Needs Study. Okay, and with that, I'll turn it over to Julie.
Thanks, Deb. There are multiple approaches to assessing transmission value. Here today, we're going to use a data-driven approach. It's based on historical market pricing patterns. So electricity prices, they vary both by location and by time. The difference in price between 2 locations at a given time indicates the instantaneous marginal value of price arbitrage. Averaging those absolute price differences over time yields the transmission market value metric that we'll use today. And that's also what's shown here on this map for the time period 2012 through last year, 2025. So just to reiterate, we're not projecting into the future, we're just assessing the past. Each line segment on this map is not corresponding to a specific piece of infrastructure like a transmission line, but instead it's showing something more general, the transmission market value between the 2 ends of the line segment. There's a lot of variability in transmission value, as you can see by the different shades of the segments on this map. But there's also high value links, which are those Typically, we say, at least $10 to $15 per megawatt hour, or the kind of orange to red color scale. Those high value links are found in many different parts of the country. On future slides, I'm going to categorize the links shown here into three groups, so I want to explain that up front. The first group is cross-interconnect links, so those spanning between SPP in the west, for example, this one, or connecting ERCOT with the rest of the country. The second group is interregional links, which cross the gray regional boundaries shown here, and then within region links stay, within one of these zones. We looked at how the transmission value that we just saw displayed on the map, how that's distributed over time. And one thing we found is that it's not evenly distributed. Instead, the top 5% of hours typically comprise around 40 to 60% of the total value. That was just for 5% of the hours. This is true over the long run, this 2012 through 2025 period, but also true if you just look on the right side within 2025. Though the value is a little bit less concentrated in the top hours, they're still well overrepresented. Thinking about the value, moving on from the value distribution to the absolute value, how did 2025 compare to other years? Looking at these time trends, one thing to point out is that as a group, cross interconnect links in the purple tend to have the highest values year in and year out, followed by the interregional links and then the within region links. But for all of them, 2025, on average, wasn't a notably high or low value year. Those averages, though, obscure that 2025 was really noticeable or notable for different individual links. The map on the left shows transmission market value just for 2025. And if you compare this link by link to the first map that we looked at a couple minutes ago with the long run value, you get this picture on the right where purple indicates that the 2025 value was below the long run average. And then the red indicates that the value was above the long run average, like for the same link. We're going to take a closer look toward the end of the webinar at some of these that stand out as being, different from their usual behavior. But for now, I want to move on to a different capability of the tool. And that capability that I think is pretty neat is to explore the direction of the price spreads. And in doing that, we'll sometimes find links where one side is consistently higher priced, and therefore the value would be captured by energy being transferred always in the same direction. On the left-hand side, these three links are examples of that pattern. They have really stable high and low price sides. Um, the three examples here are the top row. They're both between northern New York and then New York City or Connecticut. And then on the bottom row, another example of this is in the PJM region, the link between Ohio and Dominion in Eastern Virginia. On the flip side, some links have a really directionally balanced value, where which side is the higher price, regularly alternates between the two sides. The three most balanced links that we studied are shown here. One is between Western ERCOT and New Mexico. One is between Ohio and New Jersey. And one is between Wyoming and the northern part of SPP in Nebraska. Keep in mind that the arrows that we're showing here, these are based on the real-time market prices, but they're not showing actual power flows. We kind of separately have a paper where we looked into for interregional electricity trade, how the direction of the trade corresponded with the direction of the prices, and we found that it often doesn't line up with expectations. That's all I'm going to say about that for today, but if you're interested, feel free to follow up on that topic. One thing that was interesting to me when I looked at these two categories of links was that we saw the same region, this Ohio hub in PJM, as part of both categories. It has one link where the value is really in a consistent direction and one link where it's balanced. And so I thought it'd be interesting to explore these two links further as a case study and show you through doing that how the tool can help you start to understand these dynamics. So let's start with the link between the Ohio and Dominion hubs. The value of this link over time is shown by the pink line with the bars representing the within region peer group. There are year-to-year fluctuations, but no real clear, like, kind of long-run trend jumps out at you. 2025 did see an uptick over the past 2 years, though. This graph breaks down the value both by direction and by year. So the years are on the horizontal axis, and the blue bars correspond to value associated with higher prices in Dominion, aka valuable exports from Ohio to Virginia. And the smaller orange bars correspond to higher prices in Ohio, where there is sort of between or across the years a consistent small value associated with Ohio importing from Dominion. Narrowing in on just 2025, you'll see that transmission value spiked in January, which ended up comprising 30% of the year's total value. Um, but there were also, higher values in the winter months toward the end of the year, too. This is just for 2025. It's not shown here, but I did use the tool to confirm that this seasonal trend with a higher value in the winter does appear consistent over the longer term. Let's switch and look at the link between Ohio and New Jersey. We again see a transmission value. It varies year to year, no big, clear, long run trend. That's similar to the last link. But where things start to differ is when we look at the value balance. In the early 2010s, New Jersey typically had higher prices. That's the tall blue bars. Um, but starting after 2015, the relationship changes, and Ohio is the one that more often has the higher prices. This kind of change over time results in the overall picture of the link being very balanced that we kind of saw at the outset. Diving into 2025 specifically, we see winter value spikes in January and December um, associated with higher prices in the east. Again, that's similar to what we saw between Ohio and Dominion. But the difference is that now there are times the rest of the year where we see significant orange bars. That is, significant value from Ohio having the higher price and being the importer. Another way you can cut the data in the tool is looking at the value balance by hour of the day. Doing this lets another trend emerge or another pattern, which is that Ohio tends to have higher prices both in the late morning and in the evening. So this, like walking through these examples, this has provided some insights, but it certainly hasn't provided, all of the answers. What the tool is really good at is it provides you some direction for where to look next and what questions to try to answer. So for example, this leaves me wanting to answer, what is causing Ohio to want to import more than export in the evenings? And to look into the third side of this triangle, which is between New Jersey and Dominion. And if you do that, you'll see that that is also mostly one directional, with Dominion having the higher prices. We already saw that January and the winter months in general had high transmission value for both of those PJM links. That raises question about how weather or some other conditions impact the transmission value. And the tool lets you look into this. You can explore how prevalent 4 different conditions are during the times with the highest value. So those conditions are unforeseen intraday variation, which would be something like a forecast error, high net load, cold weather, and high renewable generation. Let's just narrow in on the cold weather section. And the yellow and orange markers here are those two links that we're looking into. And what this tells me is that cold weather was important for these two links. It explains or it coincides with a lot of the top transmission value. So it isn't just a coincidence that we saw high value in January and in the winter months. It did occur on the very coldest days. It also tells us that this sensitivity to cold weather is somewhat unique comparing to other within region and interregional links. Few were as impacted by cold weather as uh, these two links in PJM. However, for some cross interconnect links, primarily those connected to ERCOT, cold weather is super important. So this closes the chapter on this PJM case study, at least for today. You can use the tool to explore the links further if you're interested. Moving on to some balanced links in other parts of the country to see what we can learn, I also noticed using the tool seasonal patterns. The first example is in ERCOT between the South and Houston hubs, which is more or less an east to west link. And it here, Houston having the higher prices is in orange, and we saw that that is what happened in the first half of the year. And then in the second half of the year, uh, things changed. It trended towards South Texas having the higher prices. Another balanced link is a much shorter one, but between New York City and Connecticut. And what we see here is that looking at the winter months, they're kind of variable or balanced. But what is clear is the summer trend that in June and July in 2025, it was the imports to New York City that were valuable. I promised we would come back to this map looking at how 2025 was different from the long run pattern for all of the links. And I want to highlight some of the ones where we saw the biggest differences from average to see what was going on. So the first one we'll look into is between Arizona and Utah, which was a case of having much lower value than average. We can see that lower value here as well by the fact that the 2025 bars combined are kind of lower than the typical long run trend. Also, this time trend shows us that when Utah is higher priced, those are the orange bars, the value over time is relatively consistent. The variability comes in from when Arizona is higher priced. There, the blue bars vary a lot more year to year. Breaking this down by the time of day over the long term, which is in this case 2016 through 2025, we see that when Utah has the higher price, it usually occurs during those midday hours, sort of the business, 9 to 5. But in 2025, the difference, that trend is still true, right? The orange bars are still higher in the middle of the day, but the difference is that there isn't so much value from Arizona importing in the morning and in the evening. My hypothesis is that this has a connection with solar generation in Arizona, given the kind of diurnal cycle that we see here, but I haven't confirmed that hypothesis. But it's a way that the tool would point you into something to look at next. Now I'm going to hand it over to Dev, who will talk through an example of a link where the value in 2025 was higher than average.
Thanks, Julie. Okay. Okay, I'm going to do a live demo of the tool. Ooh, and I need to reload it. And Julie, can you see this okay?
Yep.
Great. Okay, so this is the tool, and right now we're looking at the introductory material on the top. Oh, and before I go on, I should just mention that all the figures that Julie just showed are either directly derived from data in the tool, which you can download, or just screenshots from the tool itself. So hopefully you'll recognize a lot of the figures I will about to show you. At the top here is some introductory material, and we have links to those two publications I mentioned at the beginning. Again, these publications contain details on the methods and caveats about the results we present. So definitely recommend looking at those if you really delve into this tool. All right, here's the main interactive part of the tool. And as you can see, here's the map, which we've shown a few times, showing value across all the links. And I want to quickly just talk about some of these options you have at the top. You can select, we have different set of links on which we did the analysis in the two publications, which we build on. And so you can select which set of links. The methods in terms of what's presented in the tool stay exactly the same. So it's really just changing the map that this first option does. And so, for example, this goes to the set of links we studied in the Nature Communications paper. One cool thing about the tool is it allows you, if you looked at that paper a year ago or so, now you can get updated data on the same set of links from that was presented in that paper. I'm going to look at the needs study set of links that we've been looking at throughout the presentation. You have the choice of looking at price differences in real-time markets or day-ahead markets. And the day-ahead markets, you'll notice have a lot of grayed out areas. And this is, and also related to a question we had earlier, in the non-ISO RTO areas, the market structures are different. And until recently, there have not been day-ahead markets across the Western US. And you'll notice this large empty space in the southeastern Florida, and there are also not markets with data we can use to develop this analysis in the southeast. But in terms of the West, there is real-time data, and so we have results across all those links in the West for the real-time data. Then there's also a choice of which value metric to use. We've been looking at dollars per megawatt hour over, and that is the sort of simplest metrics because it's just the average difference between the price nodes. But you can multiply that average difference times the number of hours in a year and assumed capacity of a link and get sort of a maximum value estimate for, say, in this case, a gigawatt of transfer between the two price nodes we're looking at. And those numbers, for example, this value, if you were able to transfer, would be $267 million per year, which is quite a lot. But that is really an upper bound link, which we discuss in our, especially the Nature Communications paper. So keep in mind that these are upper bound values, not an estimate of the actual value. And this is an issue we'll address in later stages of the tool. Okay, so we talked about looking at this link in particular that was more valuable in 2025 than in the long run average, and that is this link in ERCOT North to ERCOT West. And so this, oops, I'm going to show if you click on a link specifically, then it gives you information for that link. So I'm going to zoom in a little so we can see on ERCOT, this is a link between west and the north region, but really it's a sort of west to east direction link here. ERCOT North includes Dallas and urban demand hubs. ERCOT West is more rural and includes demand for recently for the Permian Basin oil and gas extraction, and also includes a lot of Texas wind farms. Overall, this is for the time 2012 through 2025. So this is a very long record of prices. And we can see that this link is one of the lower value links across our set in the map. But we can look at the value over time here. So for this particular link, it's the orange dots, and the average value is the bars for all the links here. And we can see that the value has been going up quite a bit. And in 2025 specifically, it was $7. So still not a large value, but much higher than the long-term average. Another really interesting thing about this time trend for this particular link here is that we can see the value was close to zero in 2014 and even 15. And that's because the CREZ transmission expansion, which had a similar geography, it wasn't a single project, but many projects linking ERCOT West to ERCOT North and other regions, was completed in 2013. And so this is a marginal value metric. In other words, the value of building additional transmission right after they completed this large transmission expansion in 2013 is very low, almost zero value. And that also means that there's very little congestion between these regions at that time. So a successful build out of transmission, and that congestion went down very low. Over time, you can see that transmission infrastructure became more and more utilized, so that congestion increased, and such that the value of new transmission increased over time as well to sort of the level we're at now. We can learn some more interesting things about this link through the tool here. So this figure on the left talks about the percent of total market value that comes from a portion of hours. In this case, if we look at this 5% number, that means that the 5% most valuable hours add up to about 50% of the value. You can see that orange dot there. And behind the orange dot is the sort of spread across all the links in the map. And you see that this is right at the median link. Most links have about half their value from 5% of the most valuable hours. And this is over 2012 through 2025. But now let's start to look at individual years. So if we look at 2025, we can see that the value is now less concentrated than it was over the long run. And in fact, it's one of the least concentrated links. There's still quite a bit of value in the top 5% of hours, 28% or so, but it's lower than that 50% number, and is lower than most of the other links. So something has changed over the long run for this link that is making the value less concentrated in time. So we can explore this further with the tool by going to the directionality link. And I'm going to start us off in the past here by going back to 2018. We're still selected on the ERCOT North to West link. And now let's look at the direction that value accrues from. Okay, so here in 2018, we see that this link primarily derived value from exporting or potentially exporting electricity from ERCOT West to ERCOT North. In other words, prices were higher in the north than in the ERCOT West region, and that's where additional value from transmission could have been generated. But if we look at 2025, we now see a very different story where, in fact, the link is very balanced. And we can see that it is balanced. In fact, in 2025, there's slightly more value from bringing energy into ERCOT West than ERCOT North. And so that is a sort of unique transformation in the use case of a link, in that it is now sort of more valuable to be balanced than a single direction. Um, Many links are sort of more consistent over time than this ERCOT West to ERCOT North link. So that's that. And we can see sort of when that changed by looking. So this is the by year figure, and we can see that ERCOT West fairly recently had a big increase in value, or its share of total value. And we can see that that started in 2022 and really expanded in 2023 through last year. This corresponds, I checked the load in ERCOT West and it expanded quite dramatically over that time period. So essentially load is likely driving up price, increased load is likely driving up prices in the West. And that my hypothesis would be that that's due to increased demand from oil and gas extraction in the Permian Basin. So that sort of explains how the change occurred for this link. And we can see that the value for west to north flow of energy hasn't gone down to zero. It's just that the ERCOT West has increased a lot as a high priced side. We don't see that strong a pattern by month, but we do see this interesting trend by hour. Again, this is for 2025 specifically, and we can see that ERCOT West tends to have its higher prices relative to ERCOT North in the nighttime and dropping down significantly in the middle of the day, and the reverse for ERCOT North. So this sort of shows potentially price suppression from solar power generation in the West as well. And we can look at that trend back in 2018 as well. And I'm going to just go to the hourly trend, and we see that it's a very different sort of pattern across the day where ERCOT North is almost always higher prices, or at least when there's value in price differences, it's from ERCOT North being higher priced, and it sort of follows a typical urban demand cycle, peaking in the very late afternoon, early evening. And so that concludes what I wanted to sort of demonstrate investigating a single link might look like if you use our tool. So just to review, we saw that the value after the CREZ transmission was completed in 2013 was very low, and then value increased over time as congestion increased and the existing infrastructure was used closer to capacity. And then we saw the interesting change in use case in 2022, where the direction went from this west to ERCOT North flow to the balanced flow. And then we're also able to see some interesting details about the daily pattern in transmission value. And so that is an example of how you might use the tool. And I think we'll now turn to questions. We have lots of time to explore further or answer questions.
Yeah, there's one question that's come in, Dev, from Alejandro, saying that given transmission value comes predominantly from peak periods, how does the LBNL team, or does the team have any thoughts on how transmission planners should study transmission benefits, such as using multiple weather years or other solutions? I know it's
Yes,
something you've thought about.
I have thought about this. And in fact, we have a paper under review in focused actually on the Southeast in that case, but looking at how modeled or simulated transmission value changes with representation of those types of details. So transmission value is sensitive to these peak hours, as we've seen with the figures that show concentration. And um, so the types of conditions that lead to those peak hours are specific and rare, and it's important to include them in the simulation if you want to fully represent transmission value. And so things like having multiple weather years, and it's not just weather years, but also multiple fuel price scenarios drive differences in transmission values. And then an important aspect, we didn't get too into it in this presentation, but much of transmission value is associated with sort of unexpected changes in the between the day ahead and real time markets or market settlement periods. So things that happen in the last 24 hours before the operational period can drive transmissions substantially higher in value. So it's also important to include things like your forecast error or outages that are unexpected to generators or other transmission infrastructure. Trading off with that is the cost of including all that complexity. And so there's not sort of one right answer. If you had all the resource sources in the world, it would be great to include all that complexity when you assess transmission value from a planning perspective. Um, but it is challenging to do that. So that's sort of the trade-off that planners are facing generally.
And I think you somewhat addressed this question too, but maybe just a couple more words about the applicability of transmission values in regulatory work. Like, are they used to inform transmission planning? I know you were just talking um, about how this could be used in transmission planning, but I don't know if there's anything else to say.
Yeah. Um, Transmission is built for many different reasons, and what we're showing here is really just one of the different reasons people build transmission for. Often transmission's motivated simply by reliability issues. To the extent that prices increase during times that are also stressful from a reliability perspective, we do represent some of that value here, but um, it is really a different process that assesses reliability than market prices. Um, so the processes are wide and varied by region for how transmission building decisions are made. And so for the portion of decision that depends on the value estimate, then those value estimates are generally made with forward-looking modeling because transmission infrastructure lasts a really long time. And so just looking at past price patterns is an incomplete way to plan your future transmission system. But we hope that this type of analysis can really help ground those planning models as they look forward and help people think about what complexities to represent in those planning models. And to sort of test if their planning models are potentially missing processes that are observed in price signals in past market solutions.
I can answer Larry's question, which is just looking for a clarification. Um, and the answer is that yes, the nodes we're looking at are just pricing nodes. In some cases, there is substantial transmission infrastructure between them. In some cases, there is not. And so this is just looking at the kind of evaluation of a potential increase in transfer capability between these two locations or to nodes on the system, not a specific piece of existing transmission. And Scott, you asked about how you would use this tool to evaluate the impact of new transmission lines or capacity on electricity prices. I'll kind of offer 2 points. One is that in future iterations of the tool, we hope to do that, offer that capability directly. And then also to say that in our article published in Nature Communications, we do look at this as part of the work, uh, and we look at specifically for interregional lines and a 1 gigawatt increase in transmission capacity. We look at how uh, prices would change as a result of that increasing transmission, and then as a result, how the overall transmission value compares to the marginal transmission value, which is what we're showing here. So I guess there's a little bit of I can give you a partial answer now, or our paper can, and then uh, that's something that we're bringing in to future iterations of the tool. And then what other Berkeley tools would one use to compare the largest changes in transmission to the installation of new power generation? Um, Dev, maybe do you want to talk about that kind of trade-off between transmission or other generation or perhaps storage too?
Yeah, the well, that is something that we are hoping to address directly in our, or at least help support that analysis in future stages of this tool. So we could look at how prices might change with new infrastructure, either new transmission or new storage, or new generation. Sorry, and um, but we don't have a tool right now that directly addresses that question. We have begun to look at that question in our own analyses, but have not yet published a direct answer to that question.
And JB is interested in understanding value breakdown between capacity and energy transfers. And what I'll say is that the tool here is only looking at energy value as we're using energy market prices. Certainly, there can be value, resource adequacy value or capacity value in uh, regions supporting each other through transmission and through trade. Um, that's not something that's included here. I will put in my answer here a study we've written that starts to look at the resource adequacy or capacity contributions of interregional transmission, but this tool is focused on energy market value.
Great. And just to follow up on a little more detail on Larry's question about the pricing nodes, uh, yes, these are just looking at pricing differences between the nodes, but we did pick mostly hub or zonal nodes so that each individual pricing node represents sort of a larger area, um, so that we try to think about this as like bulk transfer between regions rather than very micro scale transfer between small pricing nodes.
And then we have a question about understanding how much of the price spread is due to interregional seams inefficiencies. This is a great question that I would love to know the answer to specifically, but I'll first say that for the regional links or within region links, uh, the answer should be zero because there aren't seams. As well, some of the what we consider interregional links here don't have a lot of seams related inefficiencies if they're just between different parts of the same uh, ISO or RTO. But for the interregional links and the cross interconnect uh, links, some of the price spread could be due to those seams inefficiencies. However, the the size of these markets is large, and the size of the existing transmission for most of those interregional and particularly the cross interconnect links, the size of the transmission is comparatively small relative to the size of the markets. And so while seems related inefficiencies tend to exacerbate or in some cases exacerbate the price spread, um, they aren't the main drivers of the prices in these large areas because the transmission itself is comparatively small. Do you have anything to add to that, Dev?
No, I guess in the tool you can see that the regional links here, which are these the darkest color links, are mostly lower value, and so that reflects likely just generally more capacity within region in terms of transmission, less congestion, and also not facing any of those inefficiencies.
Currently not seeing a queue of questions. I'll wait a few more minutes to see if any of you have other questions.
Okay, well, saving any last minute questions here, I think we will call an end to the webinar. Thank you everybody for joining, and our emails are here at the top of the screen. You can look us up, and also we'll post this webinar to the tool so you can come find the video for future reference. Feel free to reach out to us with additional questions.
Thanks all.
Uh,
Take care.
yes.